free radical substitution. So we're gonna look the mechanism for this free radical substitution. So before start, let's remember what's radical. Radical is species which contains one unpaired electron. And the radical is very reactive. Okay, so very reactive. So because it's unpaired electron, one unpaired electron, it's very reactive. Okay, so it will substitute something. Okay, so next, so free radical substitution. In which reaction we have free radical substitution? When we have chlorination of alkanes. So we know that alkanes are saturated hydrocarbons, so there are only single bonds between carbon and hydrogen, so you can not add more of chlorine or hydrogen and so on, so because only single bonds, so that's why in alkanes we will have substitution. So in free radical substitution we have 3 steps. First step is initiation, so in which you form radicals. Okay, so radicals are formed. So what will happen in initiation? So this reaction is performed under UV light, ultraviolet light. Okay, so UV light ensures that chlorine molecules will break. So here let's write, so here I have chlorine and chlorine. Okay, so when I have UV or HV, doesn't matter, so what will happen? The electron pair between chlorine and chlorine atoms will break, so break homolytically. Okay, that means one electron goes to this chlorine and second electron goes to this chlorine. So what's next? We will form 2 chlorine radicals in this case. Okay, so this is how we get our radical. So next step is propagation. In propagation, there are 2 reactions happening. In propagation, radicals are regenerated. So we regenerate radicals, So here our chlorine radical, so let's say that the reaction is alkane, so the simplest alkane is methane. So here I have CH, and CH. So I have also here chlorine radical. Okay, so what will happen? This chlorine radical is very reactive, so it will make that, so the hydrogen will form the bond within chlorine. So how it will form? So bond between CH will break again homolytically. So this electron comes here and the one electron goes to carbon. So as a result, you will get CH3 radical and plus hydrogen chloride. Okay, so chlorine radical regenerates methyl radical. So chlorine radical forms methyl radical. Next case, so our methyl radical. So here in the solution you will have a chlorine molecule. Okay, and I will have methyl radical. Yeah, methyl radical with 1 unpaired electron. So what will happen? These radicals also very reactive. So what will happen? So it wants to make a bond between chlorine. So this electron pair breaks homolytically and 1 electron goes to this on the left side chlorine. And what's next? We will form again our chlorine radical plus CH3Cl, chloromethane. Okay, so this is the propagation step. Next, in the next step, okay, so let me in next step propagation, and we have termination. Next step is termination. So you can see that radicals are used up, so radicals are used. So in termination we have 3 reactions. Okay, so first thing that we will have is here I will have chlorine, 2 chlorine radicals. It's possible that these 2 chlorine radicals reform our chlorine molecule. Okay, reform our chlorine molecule. So Cl. And next I will have methyl radical and chlorine radical also. Okay, so they will also form bond. So they will also form bond, so we will form CH3Cl. And another case, when you have in a solution you have methyl radical and another methyl. Okay, so both of them very reactive, so they will join, so they will form bond between each other. Okay, so you get CH3. Okay, so this is free radical substitution mechanism. Okay, so overall reaction, so you will have chlorination. Yes, overall reaction will look like this. So CH4 plus Cl2 forms CH3Cl plus hydrogen chloride. Okay, you may have further propagation, so that means the chlorine radical in the solution will react with chloromethane until you get tetrachloromethane. Okay, so this is a free radical substitution. Okay, so let's again remember what we said. So free radical substitution, so radical space which contains one unpaired electron and it's very reactive. So free radical substitution will be performed in chlorination of alkanes, okay, under UV light. Okay, so condition is UV light. In initiation step you form radicals, so chlorine bond breaks because chlorine bond is very weak, and you will form 2 chlorine radicals in propagation step. So radicals are regenerated. So methane in this case reacts with chlorine radical. So chlorine radical makes sure that it will break homolytic CH bond. Okay, so CH bond, so you get methyl radical and HCl. So this methyl radical can react with chlorine molecule again, so breaks the chlorine molecule into radical, chlorine radical, and chloromethane. In last step we will have termination. Radicals are used, so it means you terminate all radicals. Radicals will react with each other, forms molecules. So it's possible that chlorine radicals react with each other, forms chlorine molecule. Methyl radical and chlorine radical reacts, forms chloromethane, and methyl radical reacts with each other, forms ethane. Okay, so overall reaction for this mechanism will be look like this: CH4, Cl2, CH3, Cl plus HCl. So we can also write another reaction. So CH3Cl plus reacts with chlorine, you'll get CH2Cl2 dichloromethane. Okay, so dichloromethane can react with chlorine again, so you get 3-chloromethane, 3-chloromethane, we don't need here, 3-chlorom HCl, and this 3-chloromethane can also react with chlorine, so you get tetrachloromethane. Okay, so this is so last 3 reactions. Okay, so these are formed via further propagation when your chlorine radical will react your product chloromethane. Okay, so also remember that I'm using the Hooke's arrow. So okay, Hooke's arrow. This Hooke's arrow shows movement of single electron. Okay, Please remember that and don't forget.